Hi, welcome to our mathematics class. Today is trigonometry part 13 and today we are going to discuss different problems in compound angles, right? On part of that we have here, if a plus b is equal to pi by 4, then prove that 1 plus tan a into 1 plus tan b is equal to 2. And another one, cot a minus 1 into cot b minus 1 is equal to 2, right? How to do these all types of problems, the compound angle formulas, something like here tan a plus b formula, cot a plus b, cot a minus b, tan a minus b, sin a plus b, sin a minus b, cos a plus b, cos a minus b. These all formulas are mandatorily you have to learn. Without them you cannot proceed further. This total trigonometry itself is based on the formulas. If you know these formulas in your fingertips, then you are able to do the problems in a very nice way. Okay, now you see how we are going to do this particular problem. They given that a plus b is equal to pi by 4. Okay, a plus b is equal to pi by 4 means if you apply tan on both sides like this, apply tan on both sides, we get that tan of a plus b, this is what now, tan of a plus b is equal to tan pi by 4 like this, right? And that is 1. Once we have got tan of a plus b equal to 1, now you see tan a plus b formula, you know that this is now tan a plus tan b, tan a plus tan b by 1 minus tan a tan b like this, 1 minus tan a tan b, this is equal to 1 like this. Now you see here, now if you do the cross multiplication, this is now tan a plus tan b is equal to 1 minus tan a tan b like this, right? And let us bring this to to the left side. Then what we are going to get, tan a plus tan b plus tan a tan b, tan a tan b is equal to 1 like this we have got. Now in this particular one we need to prove it as 2. What I do is add 1 on both sides to this. Now add 1 on both sides. If you add 1 on both sides to this, what you will get is 1 plus tan a plus tan b plus tan a tan b, tan a tan b like this is equal to 1 plus 1, right? That is 2, right? It is 2 here. Now 1 plus tan a here we are having here, right? Plus in these two terms we take tan b common like this. We take tan b common. If you take tan b common, this is now 1 plus tan a, that equal to 2. Now here 1 plus tan a, 1 plus tan a. These both terms are common. That if you take common, now 1 plus tan a, if you take common, that become now 1 plus tan b, that is equal to 2. 1 plus tan a into 1 plus tan b equal to 2. See how beautifully we have got this problem. It's a very important star marked problem, such that every student should know this. Now let us prove the second part of this. For this it is very easy that you are going to apply cot on both sides and going to do the same process. We are going to observe it now. Now the second part of the problem, a plus b is equal to pi by 4 they have given here. Now apply cot on both sides, then what you are going to get, cot of a plus b, cot of a plus b is equal to cot pi by 4 like this, right? Fine. And now cot pi by 4 value is what? 1. Cot a plus b formula is cot a cot b, cot a cot b minus 1 by cot b plus cot a, right? Cot b plus cot a, this is equal to 1 like, right? Now as usual we do the cross multiplication. This is now cot a cot b minus 1 is equal to cot b plus cot a, right? If you do the cross multiplication, we are going to get this, right? Wonderful. Now what we do is, let us transfer these two to the this side, like what we are going to get is, okay, cot a cot b minus cot a minus cot b is equal to 1 we have here like this. Now what we do is, here after getting that cot A cot B minus cot A minus cot B equal to 1, you add 1 on both sides to this also, right? You add 1 on both sides to this. If you add 1 on both sides, now you see here, add 1 on both sides, we get, what we get is 1 plus cot A cot B, 1 plus cot A cot B minus cot A minus cot B is equal to 1 plus 1, like this, right? Now what we do is we take 1 minus cot A, this as one thing, and the remaining thing is what? Cot A cot B minus cot B is equal to 2, like this. Now this is 1 minus cot A plus cot B if you take common. This is now what you are getting here, right? Cot A minus 1, like this. This is equal to 2, right? And here we need to prove cot A minus 1, right? For this what we do is here, minus of 1 minus cot A we can write as minus of cot A minus 1 plus cot B into cot A minus 1 is equal to 2. Now this is now cot A minus 1 into cot B minus 1 is equal to 2. By taking cot A minus 1 as common, cot A minus 1 as common, you are going to get cot A minus 1 into cot B minus 1 is equal to 2. In this beautiful way we have got this particular problem. It's a very, very important kind of the problem for competitive exams even. Next we have the second problem. It's a very, very important, and also it is also okay, star marked problem for competitive exams. Like see here, this is now we need to prove that tan 70 degrees minus tan 20 degrees is equal to 2 tan 50 degrees, like this, right? 2 tan 50 degrees. For that what we do is, let us take tan 50 degrees, like if you take tan 50 degrees, right? Yeah, this we can write it as tan 70 degrees minus 20 degrees we can write. That is the logic here. If you take tan 50 degrees, you can write it as tan 70 degrees minus 20 degrees. Okay, by taking this we are connecting all the three, 50 degrees, 70 degrees, 20 degrees, all the three are got connected here now. This means now you have here tan A minus B formula, this equal to tan 70 minus tan 20, okay, degrees divided by 1 plus tan 70 into tan 20 degrees, like this. 1 plus tan 70 into tan 20 degrees. Right? This is what we have here. Now if you do the cross multiplication part also for this, okay, for this and this, like, right, what we are going to get out of it, what we are going to get is tan 50 degrees, right, tan 50 degrees into this, right, 1 plus tan 70 into tan 20 degrees, right, this is equal to, we have got now tan 70 minus tan 20 degrees. Okay, wonderful. Now you see this is equal to tan 50. Okay, this value is what we are going to get, tan 50 degrees plus tan 50 degrees into tan 70 degrees into tan 20 degrees is equal to tan 70 degrees minus tan 20 degrees, right? Fine, wonderful. This is what we have got here. Now if you prove that this equal to 2 tan 50 degrees, that is enough. Already 1 tan 50 degrees is here, another tan 50 degrees, and if these both will cancel, then our problem is over. How they will cancel? They will be cancelled, because tan 70 degrees you can write it as, right, you see my dear student, tan 70 degrees you can write as tan 90 degrees minus 20 degrees, that is nothing but cot 20 degrees, right? This is now cot 20 degrees. Once this is cot 20, that means in the place of tan 70 degrees we can replace by cot 20 degrees, right? That's what we do now here. Okay, fine. Once this is now tan 50 degrees you are having here plus tan 50 degrees, and this is now, you know, that cot 20 degrees. Now only we did that. Tan 20 degrees, they both will cancel, because cot equal to 1 by tan, that equal to now tan 70 degrees minus tan 20 degrees, like this, Right now tan 50 plus tan 50, you have got 2 tan 50 degrees is equal to, you have got tan 70 degrees minus tan 20 degrees. Tan 70 degrees minus tan 20 degrees. In this beautiful way, we have got this particular result. My dear students, you please observe how beautifully we have got that what. Okay, we have got tan 70 minus tan 20 equal to 2 tan 50 degrees. Right. Now we have the third problem. You need to prove that sine square 52 and half minus sine square 22 and half degree equal to root 3 plus 1 by 4 root 2. Right? You see here how we will get this is something like sine square, right? A minus sine square b, our problem. This equal to sine of, already we did that, a plus b into sine of a minus b here, right? Where here a is equal to 52 and half degree, right? And b is equal to 22 and half degree, 22 and half degree, like this, right? Therefore, your problem left hand side what you are having is sine square a minus sine square b. That is equal to, we have got sine a plus b, 52 plus 22, 74 and half plus half, 75 degrees. Sine 75 degrees minus sine square b. Okay, sine a minus b, 52 and half minus 22 and half, right? What you will be getting is sine 30 degrees, like this. Now we already did sine 75 degrees value by using sine a plus b formula. We did already. That value is nothing but root 3 plus 1 by 2 root 2, right? This is, okay, this what we have here, it is not minus, this is into here, because sine a plus b into sine a minus b, and sine 30 degrees value is 1 by 2. Therefore this is now root 3 plus 1 by 2. Okay, 2 root 2 into 2, that is now 2 root 2 into 2 become what? 4 root 2. We have got wonderfully. Now this is what? The right hand side part. And here the main application of the concept is sine square a minus sine square b is equal to sine a plus b into sine a minus b. By using this formula, we achieved this particular problem. It's a very, very important kind. Now see here the fourth problem. If sine alpha equal to 1 by root 10 and sine beta equal to 1 by root 5 and alpha comma beta are acute angles, show that alpha plus beta is equal to pi by 4. Right? How we will be proving this particular problem? Alpha plus beta equal to pi. They given that sine alpha is equal to 1 by root 10. That means, you see, my dear students, here you take the right angle triangle. This is alpha. Sine alpha, that means the perpendicular by hypotenuse. This is 1 and this is what? Root 10, like this down here. And of course, this what you are going to get if you take this as something like a, b, c. Okay, you will be getting that ac square equal to ab square plus bc square by using Pythagorean triplet, like this is 10 is equal to ab square. We don't know that ab square plus bc square. ab square equal to 9, ab equal to 3, right? This is 3. You have got here like this, right? Once we have got this, from this we can take tan alpha, right? Tan alpha value equal to 1 by 3, right? This is what? Perpendicular by base, opposite by hypotenuse, right? You put it in the bracket like this. And also they given sine beta, right? Sine beta equal to 1 by root 5, right? For this also what we do is, let us find tan beta for this. This is what? Beta angle 1 and this is root 5 we are having here, like this. And this of course you will be getting it as 2. You will be getting that as 2, right? Fine. By same Pythagoras theorem you will be getting, you know that if you take this as PQR, PR square equal to PQ square plus QR square, that means, okay, root 5 square minus 1, that is root 4, that is 2 you are going to get. Now from this tan beta is equal to 1 by 2 you have got here. Oh, wonderfully we have got tan alpha, tan beta. Now we need to prove that alpha plus beta equal to pi by 4. Let us take tan of alpha plus beta formula, right? If you take tan of alpha plus beta, this is nothing but tan alpha plus tan beta by 1 minus tan alpha tan beta, 1 minus tan alpha tan beta, like this. Now tan of alpha plus beta is equal to tan alpha value is what? 1 by 3 plus tan beta, that equal to 1 by 2 divided by 1 minus 1 by 3 into 1 by 2, like this, right? This is nothing but now, and the LCM for 3 and 2 is what? 6, 3 2's, right? 2 3's divided by 1 minus 1 by 6, right? That become what? 5 by 6. Now this is 5 by 6 by 5 by 6. This will be cancelled and this one. Once we have got tan alpha plus beta equal to 1. Tan alpha plus beta is equal to 1. Now you see here, tan alpha plus beta, you got it as 1, right? 1. That means that equal to tan pi by 4. This is what? Tan pi by 4. That means alpha plus beta is equal to pi by 4. You have got wonderfully, right? This is the way how you will do this beautiful problem, right? Alpha plus beta is equal to pi by 4. See, next beautiful problem here. If cos A equal to 5 by 13 and they given tan B equal to minus 15 by 8. Wonderful. And they given that A is in 4th quadrant and B is in 2nd quadrant. They are asking you to find sin A plus B and cos A plus B. Also determined where A plus B, in which quadrant that A plus B is lying. This is what the problem. See how we are going to proceed to this type of problems, my dear students. They given that cos A is equal to 5 by 13, like this. Cos A equal to 5 by 13. That means you see here like this, okay? A is this angle A, okay? Like let us write this as PQR, something like cos A is adjacent side by hypotenuse. Then it become 12. We are having like this 5 by 13. This becomes now what? 12, like this. Cos A is equal to 5 by 13. That means we have here this as like 5, 12 and 13, right? And from this what we are going to get? Tan A. Tan A is equal to, right? You are going to get 12 by 13, like this, right? Wonderful. Sorry. This is tan A, you are going to get 12 by 5, right? Like this, 12 by 5. Wonderful. Because perpendicular by base, like this, right? Cos A and tan A. We have got it like this very wonderfully. Because here, okay, the thing is given that A belongs to Q4, right? A belongs to Q4 means now tan A. Now A belongs to Q4. That means tan A equal to 12 by 5. We got in 4th quadrant tan become negative. That's why it become now minus. Tan A is equal to, we have got it as now, right? Yeah. We need to find what? Sin A plus B and cos A plus B. Tan A will be negative and also we want sin A. Sin A, if you get, sin A is nothing but what? 12 by 13 and that is also negative, right? Fine. Wonderful. Next, in the same way, we take here tan B. They given here like this. So tan B they have given here like this. Fine. Tan B is equal to minus 15 by 8, like this. Right, once this is this, now we take angle B, this is tan B, this is 15 and this is 8 and this is root over 15 square plus 8 square, like this, right? Root over 15 square plus 8 square, right? Once we have got that, that value is nothing but 17, I think so. Okay, fine. Now B is lying, they given that quadrant 2, that's why tan is negative here, like this. Okay, we need to find, we know cos A, sin A, we know here tan B is given, we want to find sin B and cos B, like this. Sin B, if you take, that is 15 by 17 and B is lying in 2nd quadrant, that's why it is positive. In 2nd quadrant sin is positive and we want cos B. Cos B if you take, that is 8 by 17, like this, 8 by 17. These are the informations we have got beautifully. And 8 by 17, do you think it is positive or negative? Because in 2nd quadrant cos is negative, that is now minus 8 by 17. Now you know sin A, you know cos A, you know, right? Sin B, you know, cos B, you know. You can find sin A plus B and cos A plus B with the given information and you can do whatever you want to get, right? Now let us okay, fine. Let us find these values. After getting these values, now you see, my dear students, Okay. Fine. Now sin A plus B formula now. This is what sin A plus B. This is equal to sin A cos B plus cos A sin B. Right? This is what we have here. Like now, let us put these values what we have got here like this. Right? From that we have got sin A equal to, because minus 12 by 13 sin A and cos B. Right? Sin A into cos B, and we have got this as minus 8 by 17 like this. Sin A cos B plus cos A sin B, right? Cos A sin B. Cos A you have got as 5 by 13, because that lies in fourth quadrant. 5 by 13. Sin A cos B plus cos A sin B, that is 15 by 17 like this. 15 by 17. Because B is in second quadrant, we have got it as positive like that. If you simplify that value, you are going to get, that is now minus into minus, 12 8s are 96 divided by 13 sevens. We have got 221, right? This is 221 plus, right, 15 5 75 by 221. We have got this, and this value 96 plus 75 total, if you do that, 171. This is 171 by 221, that is positive. Right, in this way you have got this one, and sin A plus B you have got it as positive, right? That means, right, okay, fine. First let us find sin A plus B we have found. Now next we find cos A plus B value. This is nothing but now cos A cos B minus sin A sin B, like this. Minus sin A sin B. Now, right, cos A cos B. Already you know that cos A equal to 5 by 13, right? And the cos B value is minus 8 by 17 like this, right? Minus 8 by 17, wonderful. Minus, okay, and minus sin A value is minus 12 by 13, and sin B value is 15 by 17. And this is minus into minus plus. If you simplify this part, and you will get it as minus 40 by, this is now minus 40 by 221 plus, this is minus into minus plus 12 into 15, right? 12 into 15, that become 180. 180 by 221 we have got. This become 140 by 221. This is positive like this, right? Now sin A plus B you have got positive, cos A plus B you have got positive. That means both become positive. This is possible only when A plus B lies in first quadrant. A plus B should lie in quadrant 1, then only this is possible like this. If A plus B lies in quadrant 1, then only this is possible, right? Very good. This is the way how we will do this beautiful problem. Next we have one more interesting problem, that is prove that cos 9 plus sin 9 degrees by cos 9 minus sin 9 degrees equal to cot 36 degrees. You see, you take the left hand side part, this equal to now cos 9 degrees plus sin 9 degrees divided by cos 9 degrees minus sin 9 degrees, right? This is what we have here. What we do is we divide numerator and denominator by, see here, divide numerator and denominator by cos 9 degrees like this. Then what you will be getting is this now cos 9 degrees plus sin 9 degrees whole by cos 9 degrees. Now this is cos 9 degrees minus sin 9 degrees by cos 9 degrees like this, right? This is now cos 9 by cos 9, that is 1. Sin 9 by cos 9, that is now tan 9 degrees divided by cos 9 by cos 9, 1 minus tan 9 degrees. You are having like this. Now 1 plus tan 9 degrees by tan, 1 plus tan 9 degrees by 1 minus tan 9 degrees. This is nothing but tan, okay, 45 degrees plus tan 9 degrees divided by 1 minus tan 45 degrees into tan 9 degrees like this, right? This is equal to, of course, we can write it as tan A plus B formula, right? This is, of course, tan A plus B formula. That means tan 45 degrees plus 9 degrees, right? And that equal to tan 54 degrees. And tan 54 degrees you can write it as tan 90 degrees minus 36 degrees. right? Tan 90 minus theta, cot theta, that means cot 36 degrees you have got. That means you have taken left hand side and you have got the right hand side part. Very nice way we did this particular problem. You please observe. Next we have one more important problem, right? This is what we have here. Show that cos 42 plus cos 78 plus cos 162 degrees is equal to 0. This is what you require to prove. You take the left hand side part here. Cos 42 you can write as cos 60 minus 18 degrees plus cos 78 you can write as cos 60 degrees plus 18 degrees plus cos 162 you can write as cos 180 minus 18 degrees, right? In this way you can write this particular thing left hand side, because 42 you can write as 60 minus 18, 78 you can write as 60 plus 18, 162 you can write as 180 degrees minus 18 degrees, like this, right? Once we have got this now cos A minus B formula, cos 60 cos 18 plus sin 60 sin 18 degrees, right? And this is cos A plus B, okay? However, okay, one thing we can do here, instead of doing like this, you know, cos A minus B plus cos A plus B formula, okay? Yeah, okay, cos A minus B plus cos A plus B, if you do that, this is C, cos A minus B plus cos of A plus B, if you do. This is nothing but, however, you know that cos A cos B minus, this is plus sin A sin B, plus, right, cos A plus B, cos A cos B minus sin A sin B, like this, minus sin A sin B. Here minus sin A sin B, this will cancel, you will get 2 cos A cos B, this you will get. Therefore you have got nice formula, cos A minus B plus cos A plus B equal to 2 cos A cos B. Therefore our left hand side now 2 cos A, A is now here 60 degrees into cos B, B is what now here 80 degrees, plus cos 180 minus 18, this you can write as cos 180 cos 18 plus sin 180 sin 118, like this, right? Because cos A minus B, cos A cos B plus sin A sin B, like this. Now this is 2 into cos 60 degrees is 1 by 2, and you have here cos 18 degrees here, and cos 180 degrees value is minus 1, and this is cos 18 degrees value. Sin 180 degrees is 0, 0 into anything, it will become 0. Now let us try to simplify this. This is 1 by 2, 1 by 2 and 2 will cancel, and you are having here, this is now cos 18 degrees minus cos 18 degrees, and that will give you 0, and that is the right hand side part. In this way you will be proving this beautiful problem, right? Okay, we have now the 8th problem, right? This is now express root 3 sin theta plus cos theta as a sine of an angle, right? We need to express this as sine of an angle, right? If you take here, okay, fine, left hand side only, this is only one of the expression you are having here. That means root 3 sin theta plus cos theta you are having here, right? If you have like this root 3 sin theta plus cos theta, what we do is I multiply and divide by 2, like this. I multiply and divide by 2, like this. Now this becomes 2 into this, we can write as root 3 by 2 sin theta plus 1 by 2 into cos theta, like this. Now this is 2 into root 3 by 2. This become, we can write as sin theta. This is I can write as sin theta into cos 30 degrees, like, right? Cos 30 is root 3 by 2 plus, okay, sin A cos B plus cos A sin B sin 30 degrees, like this, right? Now this is 2 into sin A plus B, this is now sin theta plus 30 degrees, like this, right? Sin, now 2 times of sin theta plus 30 degrees, wonderful. Okay, that now we have expressed okay, the purely in terms of, right, sine. This is what now even you can write as 2 sin theta plus pi by 6, like this, 2 sin theta plus pi by 6. In this beautiful way you can write even this particular problem, right? Now we have one more spectacular problem. This you see here, we have ABC are the angles of a triangle and none of them is equal to pi by 2. Then we need to prove that tan A plus tan B plus tan C equal to tan A tan B tan C, and cot A cot B plus that is what first one we need to prove. The second one is cot A cot B plus cot B cot C plus cot C cot A is equal to 1, like this. Right? How you will prove the first one? You see, my dear students, they given that A plus B plus C is equal to pi. Right? From this A plus B equal to pi minus C. From this if you apply tan of A plus B is equal to tan of pi minus C, like this. Right? This is now tan A plus tan B by 1 minus tan A tan B. 1 minus tan A tan B is equal to tan 180 minus C, that is minus tan C, like this. If you do the cross multiplication like this, right? If you do the cross multiplication like this, right, what we are going to get is now tan A plus tan B. Tan A plus tan B is equal to now minus tan C. If you do that, minus tan C times of 1 minus tan A tan B. 1 minus tan A tan B, right? Now this is tan A plus tan B is equal to minus tan C plus minus into minus plus tan A tan B tan C. You are going to get like this. Now from this you have tan A plus tan B plus tan C. You bring this to the left side. This equal to, you have got now tan A tan B tan C. See how beautifully you have got this particular problem. Tan A tan B is equal to what, Anna? Tan A tan B tan C, right? In this way you will be getting this particular problem. Wonderful. Now to prove the second one, you substitute tan A equal to 1 by cot A in the first result. That means you see now 1 by cot A tan A. Tan B means 1 by cot B, right? Tan C means 1 by cot C. This equal to 1 by cot A into 1 by cot B into 1 by cot C. Everything you convert into cot. Now you take LCM here, like you have cot A, cot B, cot C, right? This equal to, once cot A is there, here now cot B, cot C, plus cot B is here, now this become cot A, cot C, right? Plus cot C is here, now cot A, cot B, like this, cot A, cot B. This equal to now 1 by cot A, cot B, cot C, 1 by cot A, cot B, cot C. This will cancel. Now you have got wonderfully this result. What is this? Now cot A cot B plus cot A cot C plus cot B cot C equal to 1. That's what now you see, cot A cot B plus cot B cot C, right, plus cot C cot A. Cot C cot A is equal to 1, like this, right? This is the way how you will be getting these problems. Thank you, dear students. Thank you for watching. Please subscribe and share it.